So, hello and very good morning, dear students. By the grace of Almighty, I hope you all are doing simply great with your work. So, today we are going to start the new chapter, and its name is Arithmetic Progression and Geometric Progression. After completing matrices, we are on this topic as it is the part of the term 1. So, we are going to take this. But as you see that we will be studying only the arithmetic progression and not the geometric progression because it is reduced from the updated syllabus for examination 2022. Okay, so we will be seeing the arithmetic progression, but still I'll give you some idea about the geometric progression, what it is. Okay, so focusing on the main topic, that is arithmetic progression, let's start with the first, that is the second second word of this thing, that is progression. If I ask you the meaning of progression, so in a simple way you will define progression as the thing which moves further in whatever the increasing way or in the decreasing way, it is progressing. Okay, let's say that the water from a waterfall progressing in its way, so that is what the progression is, something or the, that means something is increasing. Okay, and if I add arithmetic with this progression, it becomes arithmetic progression, and as we know, arithmetic, which is related to mathematics. Okay, so what type of progression is becoming the arithmetic progression? With the very beautiful example, I will explain you. See, you might have, or like you every day, maybe you climb the stairs. Okay, so that is the perfect example of arithmetic progression. How? See, we know that the stairs are made with the equal lengths. That means this distance, this and this. All this distance are similar. It has to be similar. It cannot be in the unsymmetric way. So this is the best example of arithmetic progression, that with some definite difference it is increasing on its way. That is the example for arithmetic progression. Okay, so like say for example, if I write 1, 2, 3, 4 and so on up to say for example 100. So we know these are the natural numbers starting from 1 and ending on 100. So this is also an example of arithmetic progression, because with the common difference of 1, this series is progressing. Okay, so that is what we are going to study. See, this is very practical chapter. You know, you may find the application of arithmetic progression, and you can use the arithmetic progressions formulae in your day-to-day life. Okay, we'll see some practical questions also. From there you will understand that how to use those formulas in the day-to-day life. Okay, so let us emphasize on this topic more, that how and like what formula we can form. So as I said that, see, like say for example I am writing a progression 2, 4, 6, 8, 10 and so on. And if I ask you, is it a arithmetic progression? So how to detect that whether a progression is arithmetic progression or not? The simple way is to see the common difference. See, I am using the word common difference. Why I am not using the word difference? Because if I use the word difference, it means that any type of difference can be there. It is not common in each and every element. Why we are giving more focus to common difference word? Because see, 4 minus 2 is what? 2. 6 minus 4 is also 2. 8 minus 6 is 2. 10 minus 8 is 2. So can you see 2 which is differing as you move on in your progression, and is common with all the terms, right? So that is why we are using common difference. Thus, to detect whether the progression is arithmetic progression or not, you need to see the common difference. Okay, so if I ask you, so for sure it is a arithmetic progression because it is having a common difference of 2. Okay, now if we move further, you will we need to understand some like we can say the terms which are used in arithmetic progression. So let's discuss this. Okay, in the progression, the very first element or a very first term is denoted by the letter A. Okay, so in the progression, say for example, if this is the progression, then 2 is called the first term and it is denoted by A. Okay, then whatever the common difference we will get, we will be denoting that as D. So if I say for this progression, your A is 2 and the common difference is also 2 as we have calculated. How to calculate the common difference? A very easy formula: second term minus the first term. Okay, second term minus first term will give you the common difference. Okay, then comes the third thing, that is called the nth term, which is denoted by n. What do we mean by this nth term? In this progression, I wish to find, like say for example, the 17th term. Okay, so that is what in general we are saying, the nth term, which is denoted by n, which says the number of terms in it or the particular term in it. Okay, so keeping in mind these three parameters, let's understand one formula which says that an is equal to a plus n minus 1 into d. This is the very important formula which we are going to see, which we will be going to see in the chapter. And let me explain you that how this formula is generated and what is the use of it. An, which is saying that, say for example, if this is the series and I wish to find 78th term of this particular series. So what a lay person will do, he will keep on counting like 10, 12, 14, or see, if this is a very easy progression, so you can directly multiply 78 into 2. So 78 into 2 will give you 156 and we got the answer. But sometimes in a series it would be difficult for you to just track out that what will be the particular term. So for here I can easily find that is 1. But now what, with the help of this formula, how can we find? Okay, so I asked you to find the 78th term. So keeping n is equal to 78, a 78. See, this is the first term. This is denoted by A1. This is denoted by A2, A3, A4, A5. And if I need to find 78, then it would be A78. Okay. So A78 is equal to A. What is the first term of the series? 2. So 2 plus n. What is n here? 78, because we need to find the 78th term, minus 1 into d, which is the common difference we already know. Okay, so 2 plus 78 minus 1 is 77 into 2. Okay, so 2 plus 77 into 2 will give you, it will give you 154. 2 plus 154, 156. So that is how you can get any of the term of the particular series with the help of this formula, which is an is equal to, this n is in the suffix. Okay, so an we are generally calling, an is equal to a plus n minus 1 into d. Okay, and keeping the things, this is the first term, this is the term which we want, and the d, which is the common difference. So to get the any term, we must have the particular series. I hope this thing is clear to you. Okay, okay, so summing up, nth term of the series, which is an is equal to a plus n minus 1 into d. Okay, now which is what? an is equal to a plus n minus 1 into d. This is the formula for finding the nth term of the series. Now say for example, like the same series, let's take 2, 4, 6, 8, 10 and so on up to, like say for example 100. Okay, so now what I thought, like what a person will think, that let's find the sum of this series. Okay, like if this is the progression given to us and I would just want to find the sum of this series. Now what if I don't know the concept and logic of this chapter? What I will do, I will keep on calculating 2 plus 4 plus 6 plus 8 plus 10 and up to 100 I will, and it will take somewhere around 5 minutes. Okay, maybe 5 to 10 minutes. So what we have, we have one very good formula of finding the sum of this progression. How? See, first of all, let me just write the formula, that is Sn is equal to n upon 2 bracket a plus an. This is the formula which you can use. Okay, if the progression is in arithmetic progression, then only you can use the formula, otherwise you cannot use in any of the series. Okay, so as this is an arithmetic progression, so the sum of the series, okay, sum of the series means 2 plus 4 plus 6 plus 8 and so on up to 100 is Sn is equal to n upon 2 a plus an. Okay, now what? See, n, how many n are there? Okay, so first we need to find the n, that n means the number of terms, how many terms are there, then only we can write the n. Okay, so how will you find the value of n? So as we know, an is equal to a plus n minus 1 into d. An, what is an? The last term also. See, you can call this an as the last term, because we don't know what is the, like, what would be this number. So we are taking an is equal to 100. What is a with us? 2 plus, because a is 2, and we are considering an, which is the last term, as I said, an. N, we don't know, we need to find the value of n. D is how much? 2. Take 2 here, so 100 minus 2 is equal to n minus 1 into 2. 100 minus 2 is what? 98 into 2 into 2 will come here, so 98 by 2, n minus 98 by 2 will give you 49. So n minus 1 is equal to 49, n is equal to 50. So there are 50 terms in this series. See, 50 only because from 1 to 100 there are 100. So half are even and half are odd. So 50 are even and 50 are odd. So that is easy. So still we just found that n is equal to 50. Now put in this formula. So Sn is equal to n. In place of n we can put 50. So S50 also you can put. 50 upon 2 bracket a. What is a? 2 plus an. What is an with us? 100. So 50 by 2 into 102. If you cancel this, 25 into 102, you calculate, you will get the answer, that what will be the sum of the series. Okay, then what we can do, see, this formula can be molded in, this is only I have taken one example. Okay, Sn is equal to n upon 2 bracket a plus, in place of an can we put this formula? Definitely we can put. So putting in the place of an we are putting a plus n minus 1 into d. A plus a will give you 2a bracket n minus 1 into d. So you have two formula of Sn which you have to write in your fair copy. It's one formula is this and another formula is this. According to the need we will apply the formula. Okay, if we have the value of n, if we have a and an, we can directly use this formula. Otherwise this is the evergreen formula which you can use. So that is what the sum of the series formula. Okay, sum of the series. Write all these things in your fair copy, okay, in the basic part. Now let's start with the exercise. If you won't understand, no worries, no issues. In the chapter we will clear the formulas and understand the things. Okay, now we are starting with the exercise 6a. First question, write the first 6 terms of an AP, arithmetic progression. Okay, the question is, I am taking B question. we are given with a equal to 11 and d is equal to 3. We know a is the first term and d is the common difference. So for building up or just to know what is your AP, you need two things. First, the first term, and second, the common difference. Okay, because using the first term you can add the common difference and get the values. Okay, so the first term is what? A. So we can write a1, which is 11. How we will find a2? This is 11 plus the common difference, which is 14. Okay, how we will find a3? Okay, this is 14 plus 3, which is 17. But just wait, I want you to learn in this way. See, with the help of formula actually. What type of formula I am saying? See, a is what? 11 only, so no need. We will find the value of a2. How? As we know, an is a plus n minus 1 into d. Okay, so we need to find a2. Okay, because a2 we require, because a1 or a which is same, so you can write a1 equal to, which is a, which is 11, so first term is 11, a2, a plus 2 minus 1 into d. 2 minus 1 is what? 1. 1 into d is d. So a2. So a2 is equal to a plus d. A is what? 11. D is 4. D is 3. So your answer is 14. Then a3. a3 will be a plus 3 minus 1 into d, which is a plus 2d. So a is what? 11 and 2 into d is what? 3. So 11 plus 6, which is 17. So third term is 17. What will be fourth term? A plus 4 minus 1 into d, which is a plus 3d. A is 11. 3 into 3. 11 plus 9, which is 20. So you got third term. How you will find fifth term? Can you see one pattern? A2 is defined as a plus d. A3 is a plus 2d. A4 is a plus 3d. So can we write A5 as directly as a plus 4d? Okay. So because we are doing n minus 1, so you have to reduce just one number. Say for example, if I say a9, so a9 will be a plus 8d. A15, it would be a plus 14d. A30, it will be a plus 29d. So directly you can write A5 as a plus 4d. So a is 11 plus 4 into 2, which is 11 plus 4 into 3, sorry, d is 3. 11 plus 12, which is 22, and a6 will be a plus 5d. So a is what? 11, 5 into 3, 11 plus 15, which is 26. Okay, so sorry, this will be 23. Okay, and this will be 26. Okay, so that is how you have to do the work. And the second thing they have given, a is I'm taking d1. A is 4 and d is 2 1 upon 3. So now you have a as 4. We know an is this and that. Here I am just changing the values. 4 plus, this is what? 2, 3 2s are 6 plus 1, 7 upon 3. So 7 upon 3. 3 4s are 12. 12 plus 7, 19 upon 3. Is it clear? Then a3, a plus 2d. So a is what? 4. D is 7 upon 3. So it will be 4 plus 14 upon 3. Okay. 3 4s are 12. 12 plus 14, you will get 26 upon 3. So that is how. Just go on and do the find the rest terms. Okay, I hope this is clear to you. Okay, let's head to the next question. Find the mentioned term of AP. I'm taking B1. to find the 15th term of this progression. This is some progression we are given with, okay, and we need to find that what will be the 15th term of this particular series, okay. So we need to actually find A15, right? So A15 question mark. We know by formula, we know that an is a plus n minus 1 into d. So what will be A15, will you tell me? A plus 15 minus 1 into d, which is a plus 14d. Just a minute before we have seen that this case is like say A15, so it will be a plus 14d, okay. So put the values now. So we have, as we have a, the first term of the sequence, which is 18, so a is 18. What is d with us? Second term minus first term. So 13 minus 18 is minus 5, no issues. D can be minus term also. Always remember a, d and an. In this formula, a, d and an, they can be positive, negative, fraction, decimal, anything. Write this thing in the top of the copy that a, an, d can be positive, negative, fraction, but n will always be a natural number. It cannot be negative and it cannot be in the decimal, or it cannot be a irrational number, okay. So because this is the counting, this is the number of terms, and the counting cannot be done in negative or in the fraction and the decimal, okay. So write this thing. So a and d put here. So A15 is equal to a plus 14 into d. So plus minus minus 14 into 5, it will give you 70, okay. So 18 minus 70, what will be 18 minus 70? It will be, I guess, 52 minus of 52. So this is the answer. Now similarly, the same criteria, do the other questions. They have properly asked you that they will find such term in the series, okay. So do this. Coming to the next question, which is the third one, you have find the first 5 terms of the AP where nth term is 4n minus 1, okay. So first question, you are given nth term as 4n minus 1. So 4n minus, this is the nth term and you need to find the first 5 terms. So it's very easy to find. How? See, solution. How we will find a1? For n equal to 1, what will be our an? This is an given to us actually, है ना? So first you mention that given an is equal to 4n minus 1, okay. When n is equal to 1, so a1 is equal to 4 into 1 minus 1. 4 ones are 4 minus 1, which is 3, okay. Then when n is equal to 2, so a2 will be 4 into 2 minus 1. 4 2s are 8 minus 1, which is 7. When n is equal to 3, a3 is 4 into 3 minus 1, 12 minus 1, which is 11. When n is equal to 4, a4 is equal to 4 into 4 minus 1, which is 16 minus 1, 15. And finally, when n is 5, a5 is 4 into 5 minus 1, which is 20 minus 1, and the answer is 19. So that is how you have to find the 5 terms like this. So with the same criteria, please do the other 2 also, okay. So dear students, that's it for today's lecture. I hope you have understood the concept of arithmetic progression. If not, then again rewind the video, understand the concept very thoroughly and seriously. Okay, so up to the third question you have to do, and also one more thing, do the first three examples of the chapter. Write this in your fair copy. Okay, I will see that also, and up to third question you have to do. Now we'll come up with more questions in the next lecture. Till that, do practice, because practice makes the man perfect. Okay, so thank you so much. Bye bye, take care, stay safe, and stay healthy.